In this video, we're going to look at hypothesis testing for a variance or a standard deviation. We're going to do this using StatCrunch. If you have not watched any of the previous videos about like the basics of hypothesis testing or any of the means and proportions videos, you will need to go back and do that first because that has some of the background information and the processes that we're going to be using. So when we want to do this test for variances or standard deviations, we have two requirements that we want to make sure we meet. The first one is that the sample is a simple random sample, and the second one is that the population is normally distributed. That second one is a pretty strict requirement for variances and deviations, meaning if our population is not normally distributed, this test would not be an appropriate test to use because it's not going to give us reliable results. Okay, our null hypothesis is the same setup that we've had previously. Notice the symbol that we are going to use here is going to depend on if we are testing a standard deviation. We would use our symbol for population standard deviation. Or if we're going to be testing a variance, then we would use our symbol for population variance. Our alternative hypothesis are still going to have the three options that we have had previously. So we could be testing for not equal, we could be testing if it's less than, or we could be testing if it's greater than. Our test statistic. This right here is referred to as the chi-squared distribution. Now, the squared here, it is not a mathematical computation that we are going to perform. It's just part of the name. So it's similar to like a subscript. If we had n sub 1, we don't actually do anything mathematically with that one. It's just telling us this is our sample size of the first set that we're looking at. Similar with the chi-squared. This is not actually going to be squaring something over here. It's just the name of our distribution. Now our symbols over here are all ones that we've seen previously. N is our sample size. S stands for our sample standard deviation. And our sigma down here stands for our population standard deviation. Once we get that computed, our degrees of freedom that we would be using for our table would be n-1. And then from that point, you would need to choose whether you're going to use the critical value method or the p-value method. So here's our example. We have a paint company and they're going to try a new formula of paint, and they want to see if the coverage is as consistent as the original coverage. They know from past records that the data is normally distributed and that the standard deviation of coverage of the original formula was 6.78 square feet per gallon. The company took 23 samples of the new formula and found that the standard deviation was 6.23 square feet per gallon. Use a 0.05 significance level to test if the new paint formula has the same consistency of coverage as the original formula. Then find our chi-squared right and our chi-squared left value. Alright, so the first thing we want to do is we want to check off those requirements to see if it's appropriate to do a chi-squared. So our sample right here, we don't really have any indication of how they took the sample, so we're going to go ahead and assume that it was a simple random sample. And then it tells us in the problem that it is normally distributed, so we have both of our requirements taken care of. Now, our null and our alternative hypothesis. We are working with standard deviations in this particular problem, so we would use our population standard deviation, and then it tells us in the problem that the original formula had a standard deviation of 6.78. So that would be our null hypothesis. Now our alternative hypothesis, it is just asking us, does it have the same consistency? So it didn't specify if it was a better consistency or a worse consistency, it was just, is it the same? So that would imply that we are going to use the not equal to symbol. Now that we have our null and our alternative, then we can go ahead and start our computation for our test statistic. So to do our test statistic, we have to take our n-1, well it said our sample size was 23, so I would have 23 minus 1. I have to times that by my sample standard deviation squared. So my sample standard deviation is 6.23, and I'm going to square that. And then I have to divide that by my population standard deviation squared. Well, I already listed my population standard deviation over here as my 6.78 and I would need to square that. So when you punch all that into your calculator, you should end up getting approximately 18.575 or so. So that would be our test statistic. And then from that point, we would go on to decide, are we going to use the critical value method or the p-value method? Now the second part of the question here, it says find the chi-squared right and the chi-squared left value. Well, in order to do that, we are going to have to look at our standard chi-squared table. So a couple of things about the chi-squared distribution. First of all, it is not normally distributed, so we do not have symmetry like we do with our normal distribution. It's going to be a right-skewed distribution. Then with our table, the areas up here, those are to the right of our critical values, and then we have our degrees of freedom along the side here. And then the values on the inside, those are the critical values. So if we need to find our chi-squared left and our chi-squared right value, so the chi-squared left value is the value on the left, and the chi-squared right value is our critical value that's on the right. Now in order to do this, we have to use our alpha value. So our alpha was 0.05. Well, because I have two tails here, it's a two-tailed test, and the reason I know it's two-tailed was because my alternative hypothesis was a not equal. So I need to take my alpha value and I need to cut it in half, and that tells me the area that would go in each of these tails. And then the area in the middle would be 0.95 because my total area under the curve is still 1. So when I come here and I look up my chi-squared right value, I have an area of 0.025 to the right of it. So across my top here, I would come to my area of 0.025, and then my degrees of freedom for this problem, I think were 22. I think our sample size was 23. So I would come down here to row 22, and my right critical value is 36.781. Okay, that's my chi-squared right critical value. Now my chi-squared left critical value, I still need the area to the right, but you have to be careful here because my area to the right isn't just 0.95, it's 0.95 plus the 0.025. So that total area to the right here is 0.975. So then I come back to my chart and I find my area across the top there, 0.975, still come down to my degrees of freedom of 22, and my chi-squared left value would be 10.283. So those would be my critical values. Now if I go back and get my test statistic, so my test statistic was 18.5-ish, well that falls in between my critical values, which is my non-rejection region. So that would tell me that I would fail to reject the null hypothesis. So it would appear that the standard deviation of the new formula is the same as it was previously. Okay. Now let's go ahead and go into StatCrunch and see what this looks like. So in StatCrunch, we are going to go to the stat menu, to variance stats. Yes, I know we are testing a standard deviation, but our only option is titled variance stats. We would do one sample, and in this case with summary. So let's head on over to StatCrunch and see what this looks like. All right, so I've got StatCrunch open here. In order to do this problem, we're going to go to our stat menu, variance stats, one sample with summary. Now, when this window pops up, you have got to be very careful and pay attention. Notice that it asks me for my sample variance. It's not asking me for my sample standard deviation, it wants the variance. Well, our problem only gave us the sample standard deviation, so we have to do a side computation to turn that into the variance. and our variance is just our standard deviation squared. So I'm going to take my sample standard deviation of 6.23. I'm going to square that value, and when I do that, it gives me 38.8129. That's the value I enter in here. Okay, my sample size I don't have to do anything with, that's still 23. But now here in my hypothesis test, notice it has the symbol for variance. Well, our hypothesis was just written in terms of standard deviation. So I have to take my population standard deviation, that's 6.78, and I have to square it and get 45.9684. And that's the value that I need to answer in here for my null hypothesis. Then I want to come down here to my alternative, make sure I check the appropriate symbol, which I wanted not equal, and then I can go ahead and compute. Okay, so from my output chart, we can see our test statistic right here, about the same as what we got, slightly different, maybe due to rounding, and then it also gives me my p-value. So if we had wanted to do the p-value method, we could compare our p-value to alpha, and again, we would end up with the same conclusion where we fail to reject our hypothesis. So this version of StatCrunch, you have to be very careful and make sure you read carefully and keep track of whether you have variances or standard deviations, because that will make a very, very big difference when you're doing your test in StatCrunch.